And we're back. So we just finished a lesson on digital root. So we're going to bring it back to the discussion of divisibility rules. We already mentioned 2, 5, and 10 because those are very easy divisibility rules. So if it's an even number, that means that 2 is a factor of it. If it's an even number, 2 is definitely a factor. And that's why we're doing this, to help us with reducing fractions. If it ends in a 0 or 5, 5 is definitely a factor of whatever number you're worrying about. If it ends in a 0, 10 is definitely a factor of that number, whatever you're worrying about. So back to 3. We just did our lesson on digital root. We know the digital root is the sum of the digits. You keep finding that sum until you have a what? One-digit number. Okay? Now where this comes into play as far as the divisibility rules is 3. If the digital root is 3, 6, or 9, then it's divisible by 3. So if you find the digital root, and it's either 3, 6, or 9, that means that 3 is definitely a factor of that number. 100%, unless you added wrong, which is a possibility. Okay? So if we had a number, for example, 453. Okay? Now, just because it ends in 3 does not mean it's divisible by 3. It doesn't mean 3 is a factor. But, if you want to know if 3 is a factor, add up the digits. 4 plus 5 equals?
9.
Plus 3 equals?
12.
That's 12, but that's 2 digits, so we need to do 1 plus 2.
3.
So is 3 a factor? Yes. 3 is a factor of 453. Okay? So, if the digital root is 3, 6, or 9, so that makes it, so all you have to do to figure out if it's divisible by 3 is find the digital root. If it's 3, 6, or 9, then 3 is a factor. Now 6 is pretty easy. If it, and when I say it, I mean the number you're worrying about. If it is divisible by 2 and 3. So if a number is, basically, if the number is even and it has a digital root of 3, 6, or 9, then it's divisible by 6. So, is this going to be divisible by 6?
Yes. Yes. No.
Who says yes? Who says no? Why do you say yes, Rebecca?
Because the digital root is 3.
Yes, but what's the other rule for 6?
2.
So what does that have to be?
23.
No.
Oh, 5.
I'm not sure why you're saying 5. What's the rule for divisible by 2?
Even.
Is this an even number? No. So it's not divisible by 6. This one is not. Because the first thing is, if it's not even, boop, you're done. Because all even numbers are divisible by 2. That's why they're even numbers. Okay? So, then we go to 9. 9 is really easy. As long as you understand how to find the digital root. It's another digital root problem. If digital root is 9, then it's divisible by 9.
Oh, yeah.
Okay? So, if I give you a number and it's divisible by 9, what do you automatically know it's also divisible by?
3.
3.
Maybe.
Because boom, boom. Now, it might be divisible by 6 and it might be divisible by 2, but you don't know. And it might be divisible by 5, might be divisible by 10. Sorry?
Wait, never mind.
Actually, there are numbers that are divisible by all of these.
Wow.
Okay? There are certain numbers that are divisible by all of these.
You know one?
Okay?
Can I find them? You know one?
Well, I got a question for you. I want you to think about it just for a second. It's kind of a challenging question. But what could you do to figure out what's divisible by all of these numbers?
Add them up.
Not add, not add.
Multiply.
Multiply. If I multiply all these numbers, then of course, these are all going to be factors of that product, right? If I do 2 times 3 times 5 times 6 times 10, times 9 times 10, these are all factors. Well, let's do it right now. 2 times 3 equals? 5 times 6 equals? 9 times 10 equals?
90.
Okay. Then we can let's do 9. 30 times 90. You have 3 times 9 and 2 zeros.
1,800.
3 times 9.
2,700.
So it's going to be 2,700. Then we have 6. So we'll just do the regrouping algorithm. 0, 0. 6 times 7 equals?
41. 42.
Good. Hey guys, stop for just a second. Excuse me. Please think before you answer. 6 times 7 equals?
42.
Keep what's in the 1, the carrots and 10s. Excuse me. 6 times 2 equals? Plus 4 equals?
16.
So 16,200 is divisible by all of those, but that's not the only one. But just to review, even numbers, 2 is always a factor of an even number. If the digital root is 3, 6, or 9, 3 is a factor of that number. If it ends in a 0 or 5, 5 is a factor of that number. If it is divisible by 2 and 3, 6 is a factor of that number. If the digital root is 9, 9 is a factor of that number. If it's 0 at the end, 10 is a factor of that number. Okay? Let's do one example. Now, we're focusing on 2, 3, 5, 6, 9, and 10. Of course, 1 is a factor of any number, and itself is a factor of that number. So let's just try 6,280. And let's just go down the list. Well, first, what would be helpful to do first, before we start checking the divisibility rules? What might be helpful to find out? Say it, Toby. I know you're thinking it. He's thinking it. Can someone read his mind? Thank you, Nabi. The digital root. So let's find the digital root of this first. And I'm just going to put DR for digital root. 6 plus 2?
8.
Plus 8?
16.
So I have 16, then I have to do 1 plus 6?
7.
So my digital root is 7. Okay, my digital root is 7. So let's just go down the list. Is it an even number?
Yes.
Yes. So, well, first of all, we know one of the factors is 1, and another one is 6,280. We know that. We know 2 because it's an even number. 3? No, why not, Luke? Why is 3 not a factor of 6,280?
Because it is,
Who can help him out? Toby?
the digital root isn't, 3, 6, 9.
Perfect. Because the digital root is not 3, 6, or 9. Alright? Divisible by 5?
Yes.
Absolutely. It ends in a 0. Absolutely it's divisible by 5. 6?
We know it's not going to work.
Who says yes?
It's half.
Who says no? Okay, we're kind of split on this. Well, it is an even number, but is it divisible by 3? No. We just said it's not. We're not listening very well. So, it's not divisible by 6. 9?
We know it's not divisible.
Guys, the rule's right here. If
No.
the digital root is 9, is the digital root 9?
No.
Then it's not divisible by 9.
10, yes.
Okay, and then 10?
Yes.
Now, listen. There are probably other factors other than this. Actually, I know for certain there are other factors. But we're just focusing today on looking at 2, 3, 5, 6, 9, and 10. Okay, that's what we're focusing on. Let's do one more example. So the first thing to do is always figure out the digital root, because that'll help you figure out some of the divisibility rules. No, let me change this. Okay. First of all, let's find the digital root. 4 plus 5?
9.
Plus 9? Plus 2, or plus 3, excuse me? 21. Now, is that a one-digit number?
No. 3.
So we have to do 2 plus 1. So my digital root is 3. So my factors, where I know 1 and 4,593 are factors, obviously. Because every number has at least 2 factors, one in itself. Is it an even number?
No.
So it's not divisible by 2. Is the digital root 3, 6, or 9? Yes. So it's divisible by 3. Does it end at 0 or 5? No. So 5 is out. Is it divisible by 2 and 3? No. Only 3. So it's not divisible by 6. Is it digital root 9? No. Is there a 0 at the end? No. So, of these factors, the only one is 3. Now, there may be other factors out there. And that factor is because we don't have the fact buddy that we're going to talk about tomorrow. The fact buddy of 3, because 3 goes into this number obviously, but we don't know how many times. But that would be the fact buddy of 3. The other factor you would multiply times 3 to get 4,593. Okay? Alright, well I'm going to stop the video for right now. These will be on the blog.
Bye.